Good morning, or afternoon, or maybe it's evening. Whatever time it may be when you're watching this video, my name is Ed, and I want to welcome you to Train Signal. You're watching a video on configuring DNS. In this video, we have a lot to talk about. First, I'll introduce you to what DNS is, and then we'll take a look at how to install DNS on Server 2008. Then we'll talk about what DNS namespace is, see how DNS queries work, explain what a forwarder is, take a look at how caching works. And then we'll take a look at some of the specific configuration, including DNS zones, DNS records, and DNS zone transfers. Whew, that's a lot of stuff to talk about. So let's go ahead and get started. First of all, what is DNS? Well, the letters DNS stand for the Domain Name System, which is an internet service that translates domain names into IP addresses. In other words, DNS is what allows all of us to be stupid humans. Now, before you take offense to that, please understand that I too am a stupid human. As a for instance, if I want to access Microsoft's website, I'm too stupid to remember their IP address, but I am smart enough to remember www.microsoft.com. DNS would then be used to translate or convert www.microsoft.com to the IP address of their web server. Now, you may be smart enough to remember all the IP addresses of all your favorite websites, but most of the rest of us would rather remember simple names instead. Without DNS, people would probably find the internet not so easy to use, and some might just find it downright impossible. There are three main components to the DNS infrastructure. There's the DNS servers, which are responsible for answering queries. Now, queries is something that we're going to look at later on in this video, so we'll just simply say requests to translate names and IP addresses. We have the DNS database of name and IP address information, where DNS servers go to look up the answers to those requests. And then the DNS clients, who send the requests to the DNS servers. So now that you know what DNS is, let's go ahead and take a look at how to use Server 2008 as a DNS server. For this lesson, I'm going to go ahead and connect to New York Member 1, which is a Server 2008 virtual computer. Let me go ahead and connect to that now. Now, while it's connecting, I would like you to keep in mind that this is a member server, not a domain controller. There are some differences when configuring DNS, and we'll take a look at them as we go through. Okay, we're logged in, so the first thing we want to do is make sure that this server has been configured with a static IP address. Anytime you are installing a network service on a server, and those services are going to be provided to clients, you don't want to be a moving target. You want to be in one place with a static IP address. So to verify that, I'm going to click on Start, and then open up a command prompt. In the command prompt window, I'm going to type ipconfig/all. This will show us our IP configuration, and right here there's a line that says DHCP enabled, and you'll notice it says no, which means that this is a static IP configuration. So we're good as far as that goes. Let me close the command prompt window. And next, we need to go to our server manager to install the DNS server role. So again, click on Start and select Server Manager. Once in the Server Manager, select Roles, and then click on Add Roles. Now, you may notice that I don't have any other roles installed on this server. If you've been following along in other videos and you have other roles installed, you may want to uninstall them first. Windows Server 2008 has the capability of simultaneously managing many different roles, but while you're learning those roles, I find it's a lot easier if you look at them one at a time, so as to not get some kind of interference from another role, which may end up confusing you. So I'm going to go ahead and click on DNS server and click Next. Here I get an introduction to what DNS is. Click Next. And just a quick summary of what we're about to do, which is install DNS server. So I'll click Install. Now, this can take a few moments to complete the installation process. So I'm going to go ahead and pause the video while we let this fun little bar go across the screen, and I'll be right back with you as soon as it's complete. Okay, you can see here that the DNS server installation succeeded, so I'm going to go ahead and click on close. And you'll see here that we now have one of 16 roles installed, and it is the DNS server. So I'm going to go ahead and close the server manager. And let's go ahead and click on Start, Administrative Tools. You'll notice there's now an entry for the DNS console. This is the console where we manage DNS. So first, let's go talk a little bit about how we're going to configure this, and then we'll come back and I'll demonstrate some of this for you. Alright, so what is a domain namespace? Well, the domain namespace is a hierarchical naming convention that DNS uses to basically locate a given host within a given domain relative to a domain tree. Now, I've kind of illustrated that for you here. If you can kind of picture that here we have our tree. This whole thing is the tree. And right here we have our host. That's our given host located within a given domain, this one domain here, and how this domain is relative to the tree as a whole, the domain tree as a whole. Let me kind of explain how this would work. Let me clear this out of here. First of all, when we look at domain names, we go from right to left as we start at the top and work our way down through the tree. So we start off at the top here with the root domain, which is simply a dot. This is just the root domain. Matter of fact, we'll talk about it a little bit later. There's something on the DNS server called root hints, which is pretty much where a DNS server is pointed to the root DNS servers out on the internet. So we'll come back to that. But right now, the root domain is just a dot. Under that dot, or to the left of the dot in a name, would then be the top level domain. Now, the top level domains are your .nets, .coms, .orgs, .info, .gov, .edu. There's a number of them. Those are your top level domains. Then we move further down through the tree into our second level domain. And that would then be the name of, typically the name of a company. And our example here is GlobalMantics. So in this example right here, if we took just this chunk of the tree right here, that's our globalmantics.com domain. But if we move down further from there, you may remember that GlobalMantics is a worldwide organization that has some subdomains built into it. We have our North America, or what we actually just simply called NA. That would be the official name of what we called it, na.globalmantics.com. We've got headquarters, and we've got Asia. And when it comes to the subdomains here, there really is no absolute limit. I mean, you don't want to go too deep, but you could go another subdomain deep, which we've done here in going to the sales domain. And inside of that sales domain is where we have a specific host named Server A. So let me clear this all out of here. And you'll see here that host Server A has a fully qualified domain name, FQDN, of Server A, right? That's the host name, .sales.hq.globalmantics.com. And that's because it represents host Server A, that's the given host, inside of sales, that's the given domain, and how it is relative to the entire tree is along this path right here, and then it is laid out as servera.sales.hq.globalmantics.com. And that is what a DNS domain namespace is. So what is a DNS query? Well, a query is a request for name resolution directed to a DNS server from a DNS client. Now there's two types of queries. They're called iterative and recursive. Now the simple definition I put here is an iterative query is where a DNS server says, I'll tell you what I know, but that's it, even if what I know is a reference point to another DNS server. Whereas a recursive query is a DNS server saying, I will research the answer and get a complete answer for you, or a definitive no, there is no such answer. I will show both of these to you in just a few moments. But a DNS server can also be either authoritative or non-authoritative. An authoritative DNS server will either give the answer to, here is the IP address for that client, or will give what's called an authoritative no, which is where the DNS server is saying, look, I am authoritative for this namespace. I know what's in this namespace, and I'm telling you there's no such hosts. A non-authoritative DNS server, which does not really know anything about the specific namespace, will either use its cache, and we'll talk about caching in a little bit, but basically a cache is an area of memory where a DNS server can store information about recent lookups. So maybe if a DNS server looked up a given host earlier, it would still know about it. Or it will use a forwarder. And again, we'll talk about forwarders in just a moment. So how do these queries work? Well, first of all, we have a client making a recursive query for the www.globalmantics.com web server to its local DNS server. So picture you have a client just going out to its local DNS server right, in-house in its network saying, hey, do you know who www.globalmantics.com is? And the local DNS server, because it was a recursive query and because it doesn't actually know who www.globalmantics.com is, it will go out and find that answer on behalf of the client. So the first step of what the local DNS server does is make now what's called an iterative query to the root DNS server. Okay, right here, the root DNS server. You may remember from the DNS namespace, the top level is root. Well, out on the internet, there are a number of root DNS servers, which are kind of the top of they are the top of the namespace, or they can resolve the top of the namespace of the entire internet. So our local DNS server asked, do you know who www.globalmantics.com is? And because it was iterative, the root DNS server can only answer what it knows. And what it knows is, no, I don't, but I do have the IP address of a .com DNS server. Why don't you go ask that server? So the local DNS server then makes an iterative query to the .com DNS server. Hi, .com server. Do you know who www.globalmantics.com is? And again, because it is iterative, the .com DNS server can only answer what it knows. And what it knows is, like, no, I don't know who that is, but I do happen to have the IP address of a DNS server authoritative for globalmantics.com. Matter of fact, let me take a quick little break from the demonstration here and talk to you about if you've ever registered your own .com or your own internet domain. What you're doing when you're registering your own .com, so maybe you have, your favorite domain.com. When you register that, you are registering the IP address of a DNS server that's authoritative for your favorite name.com with the .com DNS servers out on the internet. And that's how they would have this answer to send back to the local DNS server. So now that the local DNS server has that, it sends out yet another iterative query to the globalmantics.com DNS server. Now, because this DNS server is authoritative for that namespace, it is able to give the authoritative response back to the local DNS server with an IP address of www.globalmantics.com, and the local DNS server can then pass that IP address on to the client. So that's the entire process. Just to review, you have a client who says, hey, local DNS server, do you know who this is? Local DNS server thinks to itself, no, but it's a recursive query, so I'm going to go out and find the answer. It says, root, do you know? Root says, nope, but you can ask .com. .com, do you know? Nope, but you can ask globalmantics.com. Globalmantics.com, do you know? Yes, I do. And then the answer is given to the local DNS server, who can then pass that answer back on down to the client. And that's how queries work. So what is a forwarder? A forwarder is a DNS server to which other DNS servers forward queries. Now there's two different types of forwarders, and in actuality there's kind of a third kind here. I'm going to kind of write it in here. If you can read my handwriting, the third one here would be called root hints. Now we'll take a look at root hints like my nice, slow, sloppy handwriting. We'll take a look at root hints when we go back and look at our server. But the other two types of forwarders are what's called standard, which is where a DNS server has been configured to look to another DNS server if it doesn't know the answer. So I'm a DNS server and I get a query and I don't know the answer. Oh, but look, I've been configured to go ask this other DNS server over here. So I'll just pass along that request. Now, a conditional forwarder is where you have a namespace tied to the forwarder. So you can have situations where a DNS server can be programmed with, hey, if you don't know the answer and the request was for a specific area of namespace, go ask this specific DNS server. Let's go ahead and take a look at how this works. Client makes a request or a recursive query of its local DNS server. Now, the local DNS server doesn't know the answer to www.globalmantics.com, but it has been configured with the IP address of another DNS server. Now, unlike all those iterative queries we saw a moment ago on the internet, where we just send back and we say, no, go ask this other guy. If this was an iterative query, then the local DNS server would respond back with, go ask that other guy. But it's a recursive query. So the local DNS server, on the behalf of the client, will make another recursive query to the forward DNS server that it's been configured to ask for any lookups that it doesn't know about. That forward DNS server then has been configured with that other type of forwarder that I'd mentioned, root hints. It's those root hints that get that server out to that root DNS server on the internet, goes through the entire internet process, and gets an authoritative response from the globalmantics.com authoritative DNS server. The forward DNS server then responds back to the local DNS server, and the local server then can respond back to the client, and the client gets its answer. So if you notice, this example right here is not really that much different than the original query that I showed you. It pretty much just has the one extra step, which is when the client asked the local DNS server and the local DNS server didn't know how to get out to the internet on its own, it was configured with a forwarder onto another DNS server. But otherwise, the process is exactly the same. Now, with conditional forwarding, we are set up pretty much for the client to ask a local DNS server. And in this case, the local DNS server has two settings. First of all, it has all other DNS domains, and it has a conditional forwarder for any queries that are asked of it for the globalmantic. This really shouldn't say www here. Let me just cross that out. This should just say any queries for the globalmantics.com domain forward to this specific DNS server. Whenever you have conditional forwarding set up on a DNS server, it will attempt to use it first. So when it looks at this query for www.globalmantics.com, the first thing it's going to do is going to say, do I have a conditional forwarder for that namespace? And if I do, then let's send it on to that server. If it was for some other name, if this client was to send a request saying, give me www.microsoft.com, well, it does not have a conditional forwarder for that, so it would do whatever it would do for any other domain, which is go out to the root DNS server. Or we could have even had it go over, let's say over here, to just another DNS server, maybe that has been configured to get out to the internet. Let's go take a look at an example of how this might work in the GlobalMantics network. In this example, we have a server here which is authoritative for the globalmantics.com domain. This particular DNS server has also been configured with a couple of forwarders, or I should say a couple of conditional forwarders. One that says any queries looking for the asia.globalmantics.com domain will be sent to this specific DNS server, and one that says that any queries looking for the na.globalmantics.com domain send to this specific DNS server. Now, our globalmantics.com DNS server has also been configured with root hints, which tell it how to get out to the internet root DNS servers if an internet host is queried. So let's look at a few examples and see what would happen. In the first example, we have our client looking for server1.globalmantics.com. It's going to send that query on to the globalmatics.com DNS server, which is its local server. And because this server is authoritative for the globalmatics.com domain, it just simply sends an answer back to the client. Simple. But what if the client was asking for server1.na.globalmatics.com? This local DNS server is not authoritative for that particular domain, and it has been configured with a conditional forwarder for the na.globalmatics.com domain. So it sends that request on to the appropriate DNS server, who then, of course, sends back an authoritative response, which goes back to the client. If the client was asking for server1.asia.globalmatics.com, then obviously the process is the same, except for it's going to conditionally forward out to this DNS server this time, who sends the answer back to the local globalmatics.com DNS server and back to the client. And finally, now we have the client asking for www.trainsignal.com. This DNS server is not authoritative for trainsignal.com. There are no specific forwarders set up for trainsignal.com domain. So what we're left with is, let's try our root hints, go out to the root DNS server. The root DNS server then is going to, of course, send back a response saying goask.com. .com will then say go ask trainsignal.com. Trainsignal.com will say, sure, here's the IP address. The IP address comes back to the globalmatics.com DNS server, who sends it back to the client. That's how this would work in GlobalMantics network, or at least that's one way it could work in the globalmatics.com network. Let's go take a look at how to set this up in Server 2008. Okay, so let's go ahead and connect back to New York Member 1, the server that we had previously set up as a DNS server. Here we go, and we're still in the DNS manager. And what I want to do is put my cursor over New York Member 1, right-click, and select Properties. In our Property sheet, there are a couple of tabs that I want to show you. The first one is the Root Hints tab. I'm going to click on that, and you'll see here that we have fully qualified domain names of a.rootservers.net to an IP address of 198.41.0.4, scrolling all the way down here through to the m.rootservers.net server with an IP address. So we have a list of servers and IP addresses, and what these are the root DNS servers on the internet. Isn't that pretty cool? There's just the 13 of them. It is my understanding, I believe there are a few more now, but for a while there were just these 13 root DNS servers. And there was actually a guy who had written an article, and he had sent it on to the United States government, actually. Fortunately, this guy decided not to follow through on what this article stated, but passed it on to our government to help protect against this. And the article pretty much explained how he could single-handedly take down the internet. Oh, and I want to say it was about 20 minutes or less is what he had said. And his methodology of taking down the internet would be basically to hack in and kill these 13 servers. Now, if you kill just these 13 root DNS servers, any names that you attempt to resolve on the internet can't get resolved. Which means, did he truly take down the internet? No. Is the infrastructure still in place? Yes, the physical infrastructure anyway. Are the web servers still up and running? Sure they are. But can the users out there in the world get to those web servers? Well, they can get to them if they know the IP addresses. But like we were talking about before, unless you have some kind of superhuman IP address database going on in your brain, you're not going to get to Google unless you know their IP address. You're not going to get to Microsoft unless you know their IP address. You're not even going to get to TrainSignal unless you know our IP address. So that's how this guy was talking about taking down the internet, or at least taking it down as we know it today. Now, just to make you feel a little bit more comfortable, each one of these 13 servers is not an individual server. It's a full cluster of boxes that are distributed into different places. So it would be much more difficult today to hack in and take down these 13 servers than it was back. I'm trying to think of how many years ago it was. It was probably close to a decade ago that this guy wrote that article. So that's what the root hints are. It's a way of telling a DNS server how to resolve internet hosts. So let's click on the Forwarders tab. The Forwarders tab is where we can set up a standard forwarder. So if I go ahead and click on Edit, right here it says click here to add an IP address or a DNS name. And it's actually highlighted, so you don't have to even click there. I can just go ahead and add an IP address. So I'll put in 192.168.10. We'll say 202 and click OK. And you'll see here, for a brief moment, it said it was trying to resolve, and then it resolved that to New York DC2, which is another DNS server that I happen to have in the globalmantics.com network. So right now, this machine is set up to resolve any queries that it may be authoritative for. And by the way, it's not authoritative for anything yet because we haven't set up that aspect of the DNS server yet. So right now, if any queries come to this DNS server, since this server really doesn't know anything, it's going to send those requests to 192.168.10.202 to satisfy those requests. So that's how a standard forwarder would be set up. So let me go ahead and click on OK. Now let me show you how a conditional forwarder works. You'll notice right here we have a container object specifically for conditional forwarders. So I'm going to right click on that object and select New Conditional Forwarder. Once in the New Conditional Forwarder window, I have to first type in the name of a DNS domain that I want to set as the condition, meaning for this domain name, send to this server. So I'm going to put in na.globalmantics.com. And then down here, we click to add the IP address or DNS name. So I'm going to put in 192.168.10.205, which is the IP address. Matter of fact, let me click away from it. You'll see it resolves to Chicago DC1. Chicago DC1 is a domain controller in the na.globalmantics domain and is also a DNS server for that domain. Now right here, this may have, if you're following along, this may have also happened to you. You'll notice the red X, and then it says the server with this IP address is not authoritative for the required zone. Sometimes this can happen briefly when you first put it in. So if you know that that's not true, go ahead and click OK. You'll notice we now have the na.globalmantics.com conditional forwarder. I'm going to right click and go back to the properties for that particular conditional forwarder. Here you see the IP address and the server. I'll click on Edit, and you'll notice I now have my green check mark. It has been validated. So don't worry if you do see the red X if you know that what you've entered in is correct. Sometimes you just want to leave and come right back in. So that's how you set up a conditional forwarder. So go ahead and click OK, back out of there, and OK, back out of there. And if I wanted to set up an additional conditional forwarder, that's hard to say, additional conditional. Right click, New Conditional Forwarder. And of course, we have asia.globalmantics.com. And the IP address for a DNS server authoritative for that domain is 10.208. Again, I get my red X saying it's not true. I assure you, well, here, just to show you, I will go back in. Matter of fact, not so much to show you, let me validate, make sure it works. There we go. You always want to go back in if you do get the red X and validate that it is okay, because you may be certain that you've done something right, and in actuality you may have had a typo or something you didn't realize was correct. So now the way this server has been set up is any queries that come to it, it really doesn't know anything. We haven't made this DNS server authoritative for anything yet. We'll get to that in just a little bit. But for right now, this server has been set up that if a query comes in that has been made for the na.globalmantics.com domain, we know to send it to this IP address. If a query comes in for the asia.globalmantics.com domain, it goes to this IP address. If a request comes in for any other domain, go to the property sheet here. We'll see here that it will be sent to this particular DNS server. Now, if we get rid of, let me go ahead and edit and actually delete that out. I'll click OK. At this point, since I don't have any other forwarder, then any other requests that I get, I'm going to send out to the root hints. So that's how this particular DNS server currently works. Now there's more to configuring this DNS server, so let me take you back and we'll go have a little chat about how caching works, and then we'll come back to our server. So how does caching work with DNS? Well, there's a number of things I want to talk about with you real quick here, and then I'm going to take you back to our server and see how it all looks. First of all, DNS caching, why do we have it? Well, we have it to provide faster query responses and to reduce network traffic. Now, how does this happen? Well, all DNS servers and clients have a cache, or an area in their own local memory where they store the responses to recent queries or recent lookups. See, what happens is when a client makes a request of a DNS server for the IP address for a host, the DNS server goes out there and finds the answer. Before that answer is sent back to the client, it stores it in its local memory. That way, if another client comes in with the same request, it doesn't have to go back out to do the research. It just gives the response, which is much quicker. And of course, reduces the network traffic of having to go back out onto the network to do the lookup. Now, a client also has a cache, so when that response is sent back to the client will put it in its local memory, its local cache, so that if that same client has the same request, it doesn't even have to go back to the DNS server. Much faster, obviously reduced network traffic. Now, another nifty little thing here is we have something called a caching-only DNS server. See, that's what New York Member 1 currently is. We've set it up with the DNS server role, which means it has the ability to do name resolution and respond to client requests. But it's not authoritative for any domains. So the only thing it can do is be configured as it is right now with root hints for internet lookups and a couple of forwarders. We had a couple of conditional forwarders for a couple of other domains. And when it gets a query request from a client, it will either go out to those other, either NA or asia.globalmantics.com DNS servers as part of the conditional forwarding, or it'll go out to the internet root servers to satisfy that request. But what it will also do is when it gets the response to that request, it'll store it in its local memory, in its cache. At which point, if another client were to come in, it can service it much faster. And this comes in quite handy because those conditional forwarders are coming from a New York DNS server, and they're going out to a server where we have in Chicago and a server out in Tokyo, which are most likely going to be over slower WAN links, and we want to reduce that traffic. So we'll go back and take a look at that all in a minute. Matter of fact, another thing we'll take a look at in a minute is how to clear the DNS server cache. It can be done either with the DNS console or through a command prompt utility called DNS command. Now, why would we want to clear out the cache? Well, all information is stored in the cache for a set amount of time, and that amount of time is determined by a property on the query response, which is called time to live. This is a property that the authoritative DNS server puts on the response to tell the client or other DNS server, hey, this is how long I think this name and IP address should be good for. But sometimes that time to live is set too long and a change is made, and now what happens is the client goes out, makes the request, and the server gives a response, but that response is no longer correct. So that's why we might want to clear that cache out. Now, we can also clear the cache, or sometimes we refer to it as flushing the cache, on a client by using ipconfig/flush DNS from the command prompt. I'm going to show you all of this in just a few moments, but let me see if I can demonstrate how caching really works in a network. Here we have an example where we have a client making that recursive query to its local DNS server, right? Recursive query www.globalmantics.com. And what does the local DNS server do? Well, it goes out and it does a series of iterative queries out on the internet until it gets an authoritative response back from the correct DNS server. Now, the last time I had this same drawing up on the screen, the next thing that followed was a response back to the client. But that wasn't completely accurate. what it does next is it puts that response into its local cache. It says, okay, I'm going to go ahead and store the fact that www.globalmantics.com is IP address 172.16.38.45. Then it goes on and sends that response back out to the client. Now, the reason it did this is because now we have client 2 making another recursive query for www.globalmantics.com, the same name. This time, instead of the local DNS server going out to the internet, it can just go into its cache and say, oh, hey, wait a minute. I know that name is this IP address, so I do not have to go out to the internet. I can simply reply right back to the client with this IP address, and boom, you're done. That saves a lot of time and a lot of network bandwidth. Let me show you how this cache looks in Server 2008. So let's pop back into our New York Member 1 server. There we go. We're still on our DNS manager. And there's a couple things I want to show you, and then we're going to see if we can make this all work. First thing is I want to show you there's a container here for cached lookups. Now, if we highlight this right now, we just have root, and there's really nothing in there other than the root servers. In other words, it's all, we haven't done anything yet, so it's all empty right now. But I want to show you that if we were to right-click on our server, there's a selection for Clear Cache. If I click on that, that's how I would use the DNS console to clear the cache if I thought there was something invalid in that cache. Now, another way I could do it is by right-clicking on the cache lookups themselves, and again, selecting Clear Cache. It doesn't really make a difference. You can choose whichever one you want. It does the same thing. Now, another way we can clear the cache is through the command prompt. So let's go ahead and open up a command prompt. And I'm going to type DNS command. And instead of putting in the actual command, let me just do a quick /?. And this shows you that there are a lot of different options available on this particular DNS command utility. The DNS command utility is pretty much a way of using the command prompt to do everything you would otherwise do in the console. Works well if you're trying to script something. Here you'll notice there's a switch for clear cache. So let's put that in, DNS command /clear cache. And the command has completed successfully. Now, another thing we can do from the command prompt is let's now kind of do a little kind of like a little Wayne's World, if you're familiar with that movie, little doo doo doo, and now I'm not a server anymore. Now I'm a client. As a client, I can use the ipconfig command, and again I'm going to do a /?, to show you that there are a few things that we can do that are related to the DNS cache. One thing we can do here is display DNS, which will show what's in the DNS cache, and then we have flush DNS to clear it out. So I'm going to go ahead and put in ipconfig /display DNS, and let's take a look what's in our cache. You'll notice there's localhost, that's always there. Looks like I tried to connect to Chicago DC1, trainsignal.com. So we got a number of things in here. So let's go ahead and do an ipconfig /flush DNS, and then display the DNS cache again. And here you'll see that now all I have is localhost, and that's it. Okay, so that's how we would do things as a client. As a client, we can also flush our cache. So I'm going to go ahead and close out of this window. We'll do our little Wayne's World, and head back on over. I'm now a server again. And what I want to do is see if we can't make this all work. So even though I just did my little Wayne's World back to being a server, I'm always kind of acting as a client and a server, as a member server. And so what I need to do is point to myself for my DNS services. And let me show you what I mean by this. I'm going to click on Start, and then I'm going to right-click on Network, Properties. In the Network and Sharing Center, I'm going to click on Manage Network Connections. I'm going to right-click on my local area connection, go to Properties, highlight Internet Protocol version 4, Properties. And here you'll notice I'm presently pointing to 192.168.10.201 as my DNS server. But I'm going to change that to .100, which is the same as what my own IP address. So I'm pointing to myself for DNS. So I am my own client. I am my own server. So I'm going to click OK. Click on Close. Now I'm going to leave this window open for just a moment because we're going to need to come back here in a little bit. But let me go ahead and try to generate some network traffic, generate some DNS lookups. Let me click on Internet Explorer. Once in Internet Explorer, let's go ahead and go to trainsignal.com. See if it works. Yes, it worked. Got out to that website. And matter of fact, why don't we add to that when we go to Google? All right, we've now been to that website. I'm going to go ahead and close Internet Explorer. I will minimize these windows on our networking, bring us back to our DNS manager, because I want to show you under cached lookups, under root, you now see COM. And if I look at COM, you'll see I have Google and I have Train Signal. So I have all kinds of records. You would never imagine that there's this many records involved with some of the simplest requests out on the internet, but there are. So these are all cached, which means if any other client were to come in looking for these same items, since they're in the cache, this server would not go anywhere to look up the answer. It would go right to its cache, boom, send it back out to the server. And again, if I were to go ahead and right-click and clear the cache, you'll notice that it's gone. Everything's been gone. Everything's been deleted, I should say. And if I go back to my command prompt, do an ipconfig display DNS as a client, you'll notice that the client still has the answers for trainsignal.com. As a client, you would have to flush the DNS to get it out of your local client cache, and then display DNS, and everything's gone. Cool? So that's how caching works in Server 2008. Now let's go take a look at some of the additional configuration options. This is where we really get into the heart of how to set up DNS. We're going to look at DNS zones. Okay, so before I show you exactly how to configure a DNS zone on our Server 2008 DNS server, let's make sure we're clear on what a zone is. A zone is an area of DNS namespace. Just to keep it nice and simple, it's an area of namespace. And to be more specific, we could say we can take that zone, that area of namespace, and make DNS servers authoritative for that particular zone or that area of namespace. Now here I have a drawing of the globalmantics.com zone. Well, really it is kind of the globalmantics.com zone, but it's the entire tree. It's the entire area of namespace for this entire network. And the highlighted areas, I have one here, here, and here, are zones that we have specifically, it's actually called delegated out, and we'll talk about delegation in just a moment. But here, I've delegated out the asia.globalmantics.com zone. Okay, so I've made that its own zone so that it is now managed, or there are separate DNS servers which will be authoritative for that namespace. You'll notice that this is kind of an elongated oval that I've highlighted here, which includes the sales.asia.globalmantics.com namespace. And the reason why is because by default, any server that is authoritative for a particular zone or a particular area of namespace is also going to be authoritative for any subdomains underneath, unless those subdomains have been specifically delegated out. So here we have a couple of other examples where we have the bottom of the tree, so to speak, support.na.globalmantics.com and training.na.globalmantics.com, which have each been separated out into a separate zone and then delegated to individual DNS servers to manage that area of namespace or to be authoritative over that area of namespace. Now, zones come in a few different types. First type that we have here is something called a primary zone. Now, primary zones, matter of fact, primary and secondary, are what's known as standard zone types. This is how DNS used to work. It still does work this way if you want to, but it's not very common anymore. Basically, with the primary and secondary zone types, the primary is the master read-write copy of the zone. So whatever server is hosting the primary zone will have a master read-write copy of the zone database on its hard drive, and a DNS server hosting a secondary zone has a read-only copy of the database. So no changes can be made. It has the full database, it can respond to client requests, and it is used for that exact purpose, but updates cannot be made. Now, another type of zone that we now have is something called a stub zone. A stub zone only contains information about other DNS servers. It doesn't have a full database. Now, a moment ago, I had mentioned about delegation, or delegating other servers. We're going to talk a little bit more about those delegates and see how it relates to stub zones in a moment. But we also have something which is very common these days, which is something called an Active Directory integrated zone. Active Directory integrated zones take the place of the old primary and secondary. Now the DNS database is stored as an Active Directory object, eliminating that master read-write copy, having only a single master. Now we can use the multi-master replication topology that Active Directory provides for us. So let's talk a little bit more about stub zones. As I was saying before, DNS has delegations. You have the ability to delegate out subdomains so that they have their own DNS servers which are authoritative for that specific area of namespace. Now, before stub zones, all the delegations had to be managed manually, meaning if a parent server knew about a child server being a delegate for that specific zone, that child zone, and you add another server, the parent won't know about it unless you manually make an entry. With a stub zone, we now have automatic propagation of those delegations when new servers are added. Let's see if I can help demonstrate this for you with a little drawing. Right now, here we have our globalmantics.com domain, and you'll see that we have a couple of DNS servers here, New York DC1, New York DC2, and they are authoritative for the globalmantics.com domain. Down here, we have North America, and we just have Chicago DC1 2K8 authoritative for that domain, and we have Asia, in which we have Tokyo.dc1, which is authoritative. Now, this has been all set up manually. These servers up here, New York DC1, is going to know about this guy and is going to know about this guy, so that if any clients from the globalmantics.com domain come over to here, they will have what's called a name server record, which we'll look at a little later. They'll know about these other servers being authoritative for the child domains. The dilemma that we used to face was what happens when you add Dallas DC1 as being another DNS server authoritative for North America, or na.globalmantics.com. These guys up here do not know about that server unless you make a manual entry. When you use a stub zone, what you do is on New York DC1 as a for instance, we'll go ahead and create a stub zone which points to Chicago DC1 as being authoritative for NorthAmerica.globalmantics.com. Instead of just pointing a delegation, we're going to point a stub zone now. And by doing it as a stub zone, what's going to happen is, see, this zone is going to have just a couple of records pretty much telling it, hey, Chicago DC1 is authoritative for that namespace. But now, when Dallas, let me get rid of that drawing there, when Dallas DC1 gets added to na.globalmantics.com domain, when New York DC1 checks in, which it will do because it has a zone record, when it checks in with Chicago DC1 now had that new record added when Dallas DC1 came on, and it sends that information back up to New York DC1. Of course, these guys are all sharing information with each other, and these guys now know about Dallas DC1 also being authoritative for na.globalmantics.com. So that's pretty much how a stub zone works. Active Directory integrated zones. has many benefits. One of them that I mentioned a moment ago is the multi-master replication. We no longer have that single master, so we don't have a single point of failure anymore. We have streamlined data replication because instead of having a DNS database where replication is traveling around to the different DNS servers and an Active Directory database where replication is traveling all around, we now have put both the DNS and Active Directory databases together and replicate them all together as one. We also have the addition of something called secure dynamic updates. Now, dynamic updates is something we haven't talked about yet. We're going to get to that in a few minutes, but dynamic updates can now be secured to where only clients that have been authorized by the Active Directory database can update a DNS server, which would stop somebody generically, let's say out on the internet, from updating your DNS server. And finally, our Active Directory integrated zones are backward compatible to the old secondary zones. And what that means is an Active Directory integrated zone will act as though it is a primary zone if you have any, let's say, maybe older DNS servers out there, or maybe a Unix bind DNS server, which you want to keep around, you want to keep it functioning, it does a good job for you, but it doesn't have the mechanism to support Active Directory integration. Simply make that other old DNS server into a secondary zone DNS server, pointing to one of the Active Directory integrated DNS servers as its primary, and everything will work just fine. Another feature about zones is keeping in mind that zones can either be forward or reverse lookup zones. A forward lookup zone is where we do name to IP address. This is the most widely used form of DNS lookup. This is where stupid humans put in a name, and then the computer needs to convert that name into an IP address so that it can communicate. But we also have reverse lookup zones, and it's exactly what it sounds like. We now have our IP addresses being converted back to a name. It's not always needed. You'll find plenty of networks that just don't have reverse lookup zones. And when you do, it's usually used to meet the needs of a particular application. Certain applications have the need to use reverse lookup very often for validation purposes. Once an IP address has been given, it'll validate by doing a reverse lookup back to the name to make sure that everything is in order. It's kind of a dual checking system. Take the name to an IP address and then try to convert the IP address back to the name. Dynamic updates. Before dynamic updates, all DNS information had to be manually entered. Yes, it was as bad as it sounds. If you wanted to use DNS years ago, before dynamic updates, and you had, let's say, 100 clients on your network, you'd have to go to the DNS server and manually make 100 entries. And any changes made to those entries, you had to go back and do it manually. And you had to do it on all DNS servers. Now, records can be dynamically added or updated from the client. As I mentioned a moment ago, they can be secured with Active Directory integrated zones, meaning only clients that have computer accounts in Active Directory and can be authenticated can go ahead and make these updates. And dynamic updates can be also integrated with other network services, as for instance, DHCP. Back in the DHCP video, we mentioned the fact that you could integrate with DNS to where a DHCP server, after handing out an IP address, could then go to the DNS server and say, hey, I just gave out this IP address, why don't you make a record of it? So that's how dynamic updates works now in Server 2008. Well, that's quite a bit of stuff, so why don't we go ahead and take a look at how to configure a DNS zone in Server 2008. For this lesson, we're going to need a few different machines running, so let me go ahead and open those now. First of all, we have our New York Member 1 computer, which we've been using all along. We just recently set up DNS on it. Let me go ahead and minimize that for a moment so I can open up New York DC1, which has previously been set up as the main DNS server, if you want to call it that. I'm going to stay away from the word primary, and we'll explain why in a little bit. But the main DNS server, or we'll just say one of the DNS servers for the globalmantics.com domain. I'm going to minimize that and open up Chicago DC1, which is one of the DNS servers for the na.globalmantics.com domain. So let me put that away. Let's go back to New York Member 1. New York member 1, let me click on Start, Administrative Tools, DNS, has been set up as a DNS server, but you'll notice forward lookup zones says add a new zone. Doesn't have a zone yet. Under reverse lookup zones, there are a few zones there, but those are just there by default as part of kind of the loop back or just kind of pointing to myself. So there's really not a reverse lookup zone either. If I want to create a zone, all I have to do is I'm going to click on, or I'm going to actually right click on forward lookup zones and select new zone. In the welcome to the new zone wizard, I'll click on next. And you'll see here that I get to choose between a primary zone, secondary zone, stub zone, and then down here, it's grayed out. I don't get to select it. It says store the zone in Active Directory. But this is available only if this DNS server is also a domain controller. So an Active Directory integrated zone can only be created if you are also a domain controller. And it kind of makes sense because that's the only way to get the database into the Active Directory database. So for the first zone I'm going to create here, I'm going to go ahead and let it be a primary zone. And I'm going to click on Next. Now I need to give the zone a name. And I'm not going to make this the globalmantics.com zone name because I already have DNS servers for that. And if I were to create another primary zone, that would create problems. You only can have one primary zone for any given namespace. Otherwise, you have multiple masters. They don't talk to each other. Big problems. So let's just go ahead and call this demo.local. I don't want to give it a .com name. Demo.com might actually exist out there. So demo.local. Click on Next. Now, because this is a primary zone, a standard primary zone, we're going to go ahead and create a zone file on the hard drive of this DNS server. And the default name is fine. You could name it something else, but it would be highly unlikely you would do so. The default name is always acceptable. I'm going to click on Next. Here I get to choose between going with manual updates, meaning do not allow dynamic updates, or allow. Now notice it says allow both non-secure and secure dynamic updates. Okay, that means pretty much unsecure dynamic updates are going to work. There is another button here for allow only secure dynamic updates, but this option is only available for Active Directory integrated. We are not. So if I'm going to allow dynamic updates, they have to be allowed as unsecure or non-secure updates. I'll go ahead and I'll allow these updates to take place. And I'll click on Next. And that's it. Click on Finish. I've now created a zone, and you can see under forward lookup zones, here's demo.local. You'll see here that I have a couple of records. We'll talk about records in a little bit, but we have our start of authority record, which is kind of what it sounds like. It's the start of this particular authority or this authoritative zone. It's the first record. And there's an NS or a name server record pretty much stating that New York member 1 is a name server who is authoritative for this zone. So pretty much that's it. I have just created a zone. Now, like I said, we'll get more into these records in a little bit, but I want to show you some more zones that we can create. Let's go ahead and go back into forward lookup zones, right click, new zone. And this time I'm going to select secondary zone. In the secondary zone, click Next, is going to ask me for a name, and this time I am going to put in globalmantics.com and click Next, and now it wants to know about a master DNS server. If I'm going to be a secondary, I'm going to have a read-only copy. I need to know who my master is. Who can I get a master copy from? So I'm going to put in the IP address of, watch what happens when I click away from this IP address. It resolves, or attempts to resolve, there we go, to New York DC1. Okay, that is our primary DNS server. Or I had mentioned a moment ago, I want to stay away from that word primary because it's actually an Active Directory integrated zone, which we'll look at in a little bit. But as an Active Directory integrated zone will act as a primary or as a master to a secondary. So I'm pointing to that as my master. I click on Next and Finish. And now the globalmantics.com domain says it hasn't been loaded by the DNS server. Now the reason for this is because this particular server probably has not been given the permission to go ahead and get this zone from its master. We're going to talk about zone transfers in a little bit, and that's what this has to do with. So for right now, we're going to leave this this zone being not loaded. That's fine, and we will come back to that in a little bit. I just wanted to show you how to create a secondary zone. Now, one other thing I want to do before we leave New York Member 1, and that is reverse lookup zones. In order to create a reverse lookup zone, you right-click, New Zone, click on Next. Again, you can choose primary, secondary, whatever it may be. I'm going to go ahead and we'll make it a primary. Click Next. We're going to make it an IPv4 reverse lookup zone. We're not dealing with IPv6 right now. Click on Next. And all you have to do is put in the network ID for the given network that you're on. So 192.168.10. That's the network I'm working on right now. Click on Next. It creates a file because this is a standard primary. Next. Do I want to allow dynamic updates? Sure, we'll allow dynamic updates. Click Next. And finish. Now, if you're asking yourself why I'm so quick to go ahead and allow dynamic updates, non-secure dynamic updates may be just what it sounds like. It's not secure. It may create a security issue. That go away. But the reality is that you need to have dynamic updates. Manual updates just don't cut it. So that's another reason for really pushing the Active Directory integrated zones. But anyway, if I expand reverse lookup zones, you'll see I now have one here called 10.168.192.in_ADRA-ARPA. That is the name that is created. It's kind of a reverse order version of the IP address for the network ID. 192.168.10 is the network ID, so 10.168.192 is the name of the reverse lookup. And now this will all work. We'll now have reverse lookup for that particular area of IP addresses. All right, so that is how you create zones. There is one other type of zone that I want to show you, though. So let me go ahead and put this away. I'm going to minimize New York Member 1. And let's head on over to New York DC1. And here on the New York DC1 server, let's go ahead and go into our DNS management utility. There we go. In DNS management, I want to show you that I have a forward lookup zone here for globalmantics.com. And let's right click on globalmantics.com and go to properties. In here, there's a couple things I want you to see. First of all, we are an Active Directory integrated DNS server because we are a domain controller. If I wanted to change that, I could just simply click on Change, turn this zone into something else. We're not going to do that. Let me hit Cancel. And also, because we are Active Directory integrated, Dynamic Updates is set to Secure Only, which again, pull down the menu. Could change it if I want to. Not going to. So just wanted to kind of show you, let me cancel out of everything, how it's currently set up with an Active Directory integrated zone. Okay, under globalmantics.com, you see a folder here, and it's kind of a gray colored folder for Asia and for NA. And these folders represent delegations. There's a delegation for na.globalmantics.com, which says it has one record, it's called a name server record, which says that Chicago DC1 is authoritative for that subdomain. You'll notice it's static. Now, with this being static and with this being a delegation, if any other DNS servers were added in, we wouldn't know about it. New York DC1 would never know about it. As a matter of fact, let me go ahead and put New York DC1 away for just a moment. And I'm going to go ahead and go into Chicago DC1. And let's open up DNS for Chicago DC1. Chicago DC1, as you can see here, is authoritative for na.globalmantics.com. And in na.globalmantics.com, you will notice there's right here where it says NS for name server record, you will see that not only is there Chicago DC1, but there's also Dallas DC1. See, the delegation was created over in New York when Chicago DC1 was created. Afterwards, Dallas DC1 was created and was also made to be a DNS server, authoritative for na.globalmantics.com. And Chicago knows about it because everything within this particular zone is going to know about it. But if I go ahead and put this away for a minute and go back to New York, it doesn't show up here. The way we can get around that problem, well, first of all, we could add it manually. Meaning if I wanted to go ahead and just go to Properties and Add, I can add another server in here. So I could actually put in, I think it's 192.168.10.207. Let me see. Oh, you know what? I don't have Dallas running, so it's just going to sit there validating forever. But if I wanted to, I could manually put that in and click OK. I'm going to go ahead and hit cancel. That's how I could do it manually. But that we don't ever want to do anything manually. So how can we automate this process? Well, I'm going to go ahead and right-click on Forward Lookup Zones and ask for a new zone. And in the New Zone Wizard, I'll click Next. And this time, I'm going to go ahead and leave it as, I'm sorry, I'm not going to leave it a primary. I'm going to make it a stub zone. And let's not put it in Active Directory. We're just going to make it a good old-fashioned stub zone. Click on Next. Give it a name, na.globomantics.com. Click on Next. And, of course, since this is not Active Directory integrated, it's going to ask me to create a new file, and that's fine. Click Next. And here, it's going to ask me for a master DNS server. And the reason why is because it's a stub zone, so that means it knows it's supposed to point to some other zone to get its information. So let's put in the IP address of Chicago DC1. I'll click here. You'll notice it resolves to Chicago DC1. Click on Next and Finish. And now I have a zone for na.globomantics.com. And when I click on that, you'll see that the only records that we need to have here are the NS records and the corresponding A records. Again, we'll talk about what host or A records are. We'll talk about what all these records are in just a little bit. But this just has information about what are the other servers that are authoritative for this particular zone. And you'll notice I have Chicago and Dallas. They're both there now. Pretty cool, huh? All right, so that's how you create a stub zone. Now let me explain what all these different records are that I keep talking about. DNS has a number of different records that it uses to help resolve different things, we'll say. Just a nice simple word, things, within a DNS zone. The first record I have here is an A record or a host record. This is probably the easiest record to understand. An A record or a host record, it resolves a host name to an IP address. It is your typical forward lookup record. It says, here's a name, what's the IP address? Done. The next record is PTR record or pointer record, or sometimes known as a reverse lookup record. And it's the exact opposite of the A record or the host record. This is your typical record that you'd find in the reverse lookup zone. It resolves IP addresses to a host name. Those two are pretty simple. The next one we have here is SOA, Start of Authority. This is the first record in any zone file. It really gives the foundation. It gives the starting point for the zone database. The next record we have here is an SRV or Service Locator record. SRV resource records are used to represent a certain service that a computer may be offering. They are most typically used in conjunction with Active Directory. Active Directory requires DNS in order for its clients to locate the presence of domain controllers. When a user attempts to log in, for instance, the client machine will go out to its DNS server and say, hey, I'm looking for a domain controller for this particular domain. It's the SRV resource record, or the SRV service locator record, which will say, hey, okay, here you go. New York DC1 has the services, the domain controller services, to help you with that particular problem. And then along with an SRV resource record, you always have to have a corresponding A record or host record to then resolve that name, New York DC1, down to its IP address. Now the next one I have on the list is something we've already seen, which is the NS or name server record, which is just what it sounds like. It identifies the DNS servers that are authoritative in each zone. A new one that we haven't talked about is an MX record, or mail exchanger record. This is the type of record that we use to help email get from one point to another. When you want to send an email to somebody at trainsignal.com, there are DNS servers out on the internet that have MX records which point to our email servers here at TrainSignal. And that's how the email gets directed to that particular server. So that's what a mail exchanger record is. And then finally, this last one we have here is CNAME, canonical name, simply referred to as an alias sometimes. CNAME record resolves an alias to a host name. All right, now what the heck does that mean? The best way to describe this would be with an example. When you go to, I'm not even going to use TrainSignal, let's use Microsoft. When you go to www.microsoft.com, when you type that into your internet browser, do you think that Microsoft actually has a server out there named www? Well, they might. Well, they might not. www is a name that has become very well known for the World Wide Web, or the name of a web server for a given organization. So the reality is Microsoft might have a web server named webserver1.microsoft.com. Well, when you type in www, Microsoft wants you to then be directed to Web Server 1, so they'll create a CNAME record saying anybody that puts in www or is looking for www, they actually are looking for Web Server 1. And then, of course, along with that record, you have to have the matching A record to give the IP address of Web Server 1. So that's what DNS records are. They're the records within the database that help name resolution take place. Now let's talk about zone transfers. This is another thing that we've kind of already seen a little bit of, or at least we saw the failure of. Zone transfers are only used with your standard primary and secondary zones. They're not used with Active Directory integrated zones. Replication takes place in Active Directory integrated zones as part of Active Directory replication. When you use standard zones, primary and secondary, you use zone transfers for this replication. Now there's two different types of zone transfers. There's AXFR, which means transfer the entire database. Older versions of DNS used to have to do this every time there was an update. And then there's IXFR, which is for an incremental transfer, which is what we most commonly use today. AXFR is really only used when you first create a secondary zone to get the entire database to come over, or if something were to maybe corrupt that database and you make a request for the entire zone to be refreshed, that's when you get the AXFR. But other than that, we use IXFR to save on our bandwidth so that when a change is made, only that change needs to be transferred to the secondary. Now, DNS zone transfers very much so can be a security risk. There are a number of issues surrounding zone transfers, which means that's a whole different reason for possibly using Active Directory integrated zones. It's because just the security aspect itself, where a hacker out there might be able to create a DNS server and then go ahead and tell your primary DNS server, hey, I'm a secondary server, why don't you go ahead and throw that database at me? Well, that's a problem, and we don't really have, we have that secured much more within Active Directory integration. So let's go ahead and let's take a look at not just some resource records, but real specifically, let's look at these zone transfers, how we set them up, and how we can secure them. To demonstrate zone transfers, I'm going to need a couple of machines open. So first one I need is New York Member 1, and then I'm also going to need New York DC1. All right, so we got those both open. Let me go ahead and start off in New York Member 1. And before we get into zone transfers, let's talk about some of these records. I'm going to go to the demo.local zone. You'll see there's a couple of records that are already created by default. We have our start of authority record, which is nothing more than just, hey, here's the first record, here's the beginning of the zone. And a name server record, which says, hey, New York Member 1 is a name server that is authoritative for demo.local domain, or the demo.local zone. Now beyond that, we typically would have records added dynamically through dynamic updates, but because demo.local is not real, it's a fake zone that I've created, we're going to have to do everything manually. So I'm going to go ahead and right click on demo.local, and select to make a new host record, new A record. Now don't worry about the quad A, that's for IPv6, but it's an A record for IPv4. And we're going to give it a name, and so let's say there's a computer named Ed. And Ed's IP address, watch this is going to be cool, is 192.168.10.100, which is actually New York Member 1's IP address, but that's okay. We're just going to put in this record and see what happens. I'm going to go ahead and tell it to create the associated PTR record, the reverse lookup record, as well. Now don't worry about the time to live. That has to do with caching. We won't worry about that for right now. I'm going to go ahead and add the host. It says it was successfully created. Click OK. And done. You'll see I now have a record for Ed having this IP address. If I go to my reverse lookup zones under my 192.168.10 network and refresh, you'll see I also have a reverse or PTR or pointer record saying this IP address is for ed.demo.local. I'm going to have to remember to get that out of there as soon as I'm done showing you this, because that's definitely a false record pointing to a bad location, and we don't want to cause problems with that. But to prove that this is working, let me go ahead and open up a command prompt. I'll click on Start, Command Prompt, and I'm going to type in ping ed.demo.local. Watch what happens when I hit enter. Even though ed.demo.local is not a real machine, doesn't exist anywhere, because the DNS server thinks that it is, there is a record for it. It says pinging ed.demo.local at 192.168.10.100, which does exist. That's this machine, and I get replies. So it all works. So this is something that you may have heard of happening before. A lot of spyware does this, where it'll put false records into your DNS database so that you think you're going to one website. In actuality, it takes you to another website. That's one way they get it done. So let me go ahead and pop back over to our DNS manager. And you know what? I'm going to go ahead and delete that PTR record now before I forget. And now let's go back to demo.local and let's look at a couple other records. Here we have new alias or CNAME record. In here, let's use www. Right? That's probably the most common one out there. We're going to say that www is actually ed.demo.local. And we're going to go ahead and click OK. And so what it says is if anybody's looking for www, they're actually looking for ed.demo.local. Ed.demo.local is 192.168.10.100. So again, if I go back to my command prompt, if I type in ping www.demo.local, it now says pinging ed.demo.local because that is what the alias points to. So that's how an alias works. Now, the last record, let me go back to the DNS manager. The last record that I can show you manually here would be a mail exchanger record. I could go ahead and add a record in here, but that's all I'm doing is manually entering in a record because I don't have an exchange or a mail server set up. But this is how you would manually set up a record. Go ahead and put in the domain name, give the fully qualified domain name of the mail server itself, and then you would have an extra mail exchanger record. Now to show you the SRV resource records, I'm going to take us over to New York DC1. So let's leave New York Member 1, head over to New York DC1. And here in the globalmantics.com domain, you'll notice a number of these underscore records. Like here, I'll go to TCP. In these folders, these are the SRV or service location records. See, New York DC1 is a domain controller, or more specifically, globalmantics.com has Active Directory domain controllers, and so there are going to be resource records saying that these particular computers, you'll notice they're like New York DC1 and 2, and we got New York DC3 and 4. Many of them provide either global catalog services, Kerberos related services, LDAP services. These are the types of services that domain controllers provide so that when a client says, hey, I need to log in, the first thing it can do is go to the DNS server. The DNS server can say, well, you need these machines, these computers, because those are the domain controllers. And then, of course, if we go back to the globalmantics.com domain, down here I have the matching A records pointing to the actual IP address for those domain controllers. So that is pretty much the resource records that DNS uses. Now let's pop back over to New York Member 1. Alright, so we can take a look at how some of the issues with zone transfers. What I want to do is take a look at this globalmantics.com domain, because you'll notice it says zone not loaded by DNS server. You may recall, let me go to the properties of this zone, that this is a secondary, and it's pointing to 192.168.10.201 or New York DC1 as its master. Well, the reason it's unable to load this information is because I happen to know that New York DC1 currently has been set to prevent zone transfers. So let's go over and look at New York DC1 and see how we can fix this. If I go to the properties on New York DC1 of globalmantics.com and then go to the zone transfers tab, you will see right here where it says allow zone transfers, that box is not checked. If I check that box, and then for right now we'll leave it to any server. We'll talk about that in a minute. And then go ahead and click OK. Now I'm letting any server, any secondary server that wants to get a zone transfer to do so. So let's go back to New York Member 1. Let's first transfer. And yeah, this is what I was afraid of. Lots of times if you try to do this after the fact, you get kind of held up for a while. There's a delay. So here's what I'm going to do to simplify this delay. Let's go ahead and actually, let me click away. Oh, nice. It won't even let me delete it. Let's give me a minute here. Nice. All right, let's fix this by closing out of the DNS console and go back into the DNS console. We'll try one more refresh. That didn't work, so let's just go ahead and delete. This is something that we wouldn't have to do. When you set this up, if we were to do everything in production world exactly how we did just here, it would all work fine. You just need to give it a few minutes. To save time, I just went ahead and deleted the zone, and let's go ahead and create it now that zone transfers are allowed. So I'm going to click on Next, Secondary Zone, globalmantics.com, put in the IP address of New York DC1, and finish. Oop. And this time you will notice it loaded just fine. Okay, so now I am a secondary zone DNS server for the globalmantics.com zone. And I have all the records just like we do over on New York DC1. Now let's go back over to New York DC1 and let's look at what else we can do with zone transfers. Let's go back to the properties. Alright, zone transfers. Here's where you can decide whether you're going to allow a zone transfer or not. That's the first line of defense that you can use to protect yourself if against secondary zone servers or maybe unwanted secondary zone servers from transferring this database of information. Now, if we need to have zone transfers, the way I've now configured it is a really bad idea. If you're going to allow zone transfers, it's not a good idea to do to any server. It's a much better idea to say either only the servers listed on the name servers tab, which you'll notice by the way there's a name servers tab right here, which means zone transfers will only take place to the servers listed here. You will notice that New York Member 1 is not listed. I would have to add it manually. Let me go back to Zone Transfers tab. Or I could say only to the following servers. And then again, I could go in here and edit and put in 192.168.10.100 and it resolves to New York Member 1. Now I'm allowing zone transfers to that one particular server and it would all work fine. That is probably the most secure mechanism if you're going to have to allow zone transfers. Now, another thing that we have here is we have the ability to use something called DNS Notify. And here you'll notice it says to specify secondary servers to be notified of zone updates. So let me click on Notify. Here you'll notice that we have Automatically Notify checked. Now we could automatically notify servers listed on the Name Servers tab, So all servers on the name servers tab will get notified when a change is made. Or I again could say the following servers. Now, what is the purpose behind this? Well, the purpose behind this is so that basically the moment a change is made on a DNS server or on a master DNS server, it could go ahead and let the secondaries know about it. Otherwise, there's a time mechanism where secondaries would go in and check in every once in a while. And in that instance, you run the risk that sometimes several minutes can go by before updates are made. So this is a way to speed up the process of notifying a secondary server. So that's pretty much how zone transfers work in DNS and Server 2008. So let's go back and review everything that we've covered in this video. Well, we started off by learning what DNS is and how to install the DNS server role in Server 2008. We looked at the concept of domain namespace. We saw how a DNS query works. You should now know the difference between an iterative and recursive query. Took a look at forwarding, whether it be forwarding out to root hints, standard forwarders, conditional forwarders. We saw how DNS caching works on both clients and servers, and we even set up a DNS caching only server. We looked at the different DNS zones, primary and secondary. We took a look at the stub zone, and we also saw that we could have Active Directory integrated zones to help eliminate some of the replication traffic that's otherwise created with standard zones. We looked at the specific records that are involved with DNS, and then we took a look at zone transfers, which are used when you are using standard zones, primary and secondary zones. And one little side note about the DNS zone transfers. I talked about securing them by pointing to specified secondary servers, and that's true. That is a very, very good practice. But another thing that you could do is to encrypt the traffic, encrypt that transfer information while it's going across your network, because you don't want somebody to hack in and grab the information off your network when it's being transferred from a master to a secondary. Whew, I don't know about you, but that's about all the DNS configuration I can take for right now. So what do you say we go grab a cup of coffee, and I'll see you in the next video.